Okay, I think we are good to go now. Hello everybody out there. There's quite a few people now that are watching these things. So that's really the first thing I wanted to say was thanks for everybody for all the kind words, saying like, yeah, keep going, or asking me a million times what weird editor I'm using. It's been a lot of fun so far. So I wanted to just say, yeah, as I said, thanks. And just a little bit of a mini announcement, if I can. Over the years, like 10 plus years and even longer now, I've learned and gotten so much from the open source community, and just in general, like the tech community. Open access information, open source software, it's been such a big part of my life. So I just want to say thanks to everybody for kind of helping me give back. One of the things that I don't really ever want to do is monetize the stream. I don't want to put ads in or anything like that. That's including on YouTube and Twitch and wherever else this thing ends up. I don't want to I don't really want to do that kind of thing. I also don't really like ads, and I especially don't like all this tracking and all this stuff that's going on. I think we all know about the privacy stuff. However, I wouldn't mind a little bit of extra support from anybody who can. So the best way to support this thing and keep this thing going would probably be if you know anybody in the sort of video industry who's looking for somebody. Point them to the stream, see if they find what we're all doing is interesting, and just let's have a chat. I'm super easygoing, obviously, so yeah, I'm good to go. The other thing is that I have now made a little donation page. So where is it? If I go here and go here, so we've got this little support us, and all this is for is really just to support our hosting costs. But wait, what hosting? What are we doing here? Okay, so next announcement is that I wanted to make a stream that is just a pure, no ads, no tracking, no platforms, just a plain old server hosting video. I think that's important for the internet. I think we all know a little bit about how the internet works, and we probably have an idea of how, let's say, strange it is that most of the bytes that go through all of the wires and pipes and fiber goes through like a handful of a small handful of very large companies. So any donations would go to supporting that system. That is, maybe we can develop that together. That would be fun. The next thing is I've actually made a little discussion forum. Now I say forum, and I really don't like that word, but all this is that I'm just going to be posting updates here, kind of for myself as well, because people are asking me, similar questions. Also, if anybody's got any questions, feel free to send them in. So, how do you sign up? You don't have to sign up. This is just email. So if you want to send in a question, send an email to this address. So let's go, hello world. This is a question and a message to all the nice people out there. No, I didn't actually test this before, so fingers crossed this actually works. Let's see. Yeah, there we go. Okay. So here it is. Pretty easy. That's it. There's nothing much to it. It's got a nice interface for anybody to, read things and stuff like that. Now, to actually receive messages in your mail client, you do have to sign up. If this thing ever gets past a certain size, then we're going to have to start paying a bit more. But hey, maybe some people can donate, and we can keep the thing going. I'll also be accepting, like patches through there. So if you don't have an account on GitHub, or if you don't want to have an account on GitHub, then we're going to be sending patches around and discussing stuff in there. Also, anything to do with the stream, like if we want to cover a certain topic. A few people have sent in suggestions, but I don't really have one place to look at them because they're in chat, and they're in like YouTube chat and Twitch and like YouTube comments and other bits and pieces. So one of the things I also would be open to is if anybody knows more about mailing lists, about SourceHut, so lists.sr.ht. I've got an account there and I pay for that already. So yeah, anyway, up for any kind of discussion. I don't want it to be like a place. Just a thing to send, to all, I don't know, help each other, share information. I'm not interested in any platform or building audience or anything like that. Sweet. We done? Yeah, as I say, donation keeps our open source stuff alive too. So all of this stuff that we've been doing is actually open source under the very, very permissive license, the ISC or MIT license. So feel free to use it at your company or whatever, or wherever rather. Yeah, so I think that's all for the announcements. Sorry for that. That's probably a bit of a cringe fest. And I'll just answer a couple of questions here. Just wondering, how do you stream on multiple sites at the same time? Okay. So hi, Offline Mark. I run a tiny ffmpeg command that listens on localhost, and then OBS is connecting to localhost or loopback interface, and then ffmpeg streams it out to YouTube and Twitch. There's other services online that do that for you, but yeah, this is fun, right? Oh no, that's not elite. I think the ffmpeg project is, I think that's elite. I think that's beyond elite, whatever that is. Amazing project, amazing. Rebel Elder asks, the topic zone you have to register to be able to receive other messages. Yeah, you do. So I know you're on SourceHut, you said. So yeah, if we think that that's maybe better, or you think, yeah, I'm totally up for that too. Yeah, that's it. So let's get going. One of the things that because it's a little bit late here, I was doing a bit of boring admin work today. What I wanted to look at is what we're going to do today. Now, in our repository, there's still one file left from this package from Comcast. What I think would be really cool is to not have that file there, so that we don't have two license files in the repository. We've got this one and this one, and it would be good to not have, a bunch of this stuff. Yucky sort of random magic numbers, I don't know what that is. So what that means is we'll be looking at actually how to do this CRC32. What it is it a checksum thing? Is it, I don't think it's cryptographic, so that shouldn't be too hard and doesn't look too tricky. I mean, that looks really scary, but yeah, there's a bit scary stuff here that I think would be great to, have some, maybe not as much magic code here. There's quite a lot going on there in a single line. A lot of operations. So, actually written an issue up about it, and here we go. And if anybody's watching this on YouTube, I'm getting some messages about the bit rate being too low. So if the stream looks a bit funny on YouTube, then yeah, if anybody could write in chat just to let me know. Thanks. It seems okay to me. I'm getting weird messages. Anyway. All right. Let's have a look at this CRC32. One of the things we could start to do is to actually pull this thing apart a little bit. And because we've got a bunch of tests now, we can actually just run the tests as we go, pull apart the function, and watch it pass or fail. It's actually not a bad way to start, to be honest. Another way would be to just, actually read and find out what this thing could be doing. So first up, they're setting it to -1. And they're going through each byte in the slice, and then they keep shifting the bits left 8 times. And that operator clears the bit, is that right? Offline mark. Oh yeah, thanks. Okay. Yeah, that's weird. Just checking here. Yeah, no, I'm not doing any like retranscoding or anything like that, so not sure what's going on there. Okay. I'll just keep going. So yeah, let's see. So we're shifting left 8. And then it's accessing the table, which is this big boy. So another thing we could start is just start like this. And then we can go CRC, I think that should be the same. No. Nope, okay. I'm not allowed to do that. Okay, so we could do a let's get this value into its own line. There's a lot going on there. So the index of the array that they're accessing is BI. So the OXFF. can't even remember what that operator does in Go. Is that the XOR? Yeah. All right, so the bitwise complement is defined as the bitwise complement. So the complement would be the, let's get a little let's get a little REPL thing running. Hey Ruby, how's it going? Set this value to let's do x01. So then, and then let's print the, what might be the, that. Oh, yeah, okay, got it. So so it just flips all the bits by 1. So for example, if we have, let's do that. Let's just do value and then the XOR. Yeah. Something like that. Okay, I'll do 2 tabs. All right, let's align this thing. We're going to do it. All right. On and then that to the next tab stop is there. Yeah, nice. Okay. So now looking at this lovely bit of code here, we can start to decode the code. And if you ever need to decode code, yeah, that's I don't know, it's no good. Our sort of program language should be language, not code. Not something to be decoded, let's say. They're saying, what type of arcane magic is that? Yeah, it's no good, is it? The arcane magic is just shit code. complement let's try printing the value of n, XOR n. So this is the value of n, or XOR'd with itself. So it clears all bits and the one that's set. I think that's right. So if I go and that's going to be 1, 2, 4, 5, 6, 7, 8. Looks like I needed to do a bit of research on these bitwise operations before I started the stream, not as I'm streaming. Whoops. So the index here is actually is bi, int32 bi. So we turn the byte into a int32. And then which value is, and then this value is ANDed. So we got that. Let's get that in. We can get this. So this is the, like before the mask. Right? So that's, and then we don't need these parents anymore, so we can get rid of that. Awesome. Okay, so that's the same. The next bit is maybe have a look at what this really is. CRC32 table, okay, yeah, all right. So, but what does this really represent? I mean, does it, you know, it doesn't, I'm not quite clear what these values actually mean. So that would be the next thing. Another thing we could do is change that to P, and then we can just use B here. So for then it's a little bit clearer that we're working on a byte, so we can change that just to B, and then okay, good, still parsing. Next up, let's look at the I linked to a Wikipedia page that gives us a bit of info on the CRC32, the cyclic redundancy check. Let's have a quick read of that. CRC32. Here we go. I feel like this CRC32 could almost be in another package anyway. Similar to in Go, in the standard library, we've got crypto slash we've got like SHA-256. Is that right? Yeah. So we could just have one that's and we could have CRC32 in there. Instead, it's a little bit more like, you know, more idiomatic. But we can do that afterwards. Let's just read this. It's funny as well because this is yet another one of these you know, often when we've been working through this SCTE35 stuff, there's been so many things that are really for like analog transmission. Oh, well, sorry, not analog transmission, but you know, let's say at the level where you have noise and, you know, where sun is hitting some sort of satellite which is messing up the radio waves, which is then causing problems at the bit level. You know, we're kind of working at that level, and there's a lot there that we don't really need to deal with at the level of the software that at the applications that are probably going to be using this thing, because all of that stuff is handled deep down in sort of, you know, hardware, you know, in our network cards and stuff like that. By the time our software actually reads the bytes, that we've had all sorts of stuff happen to, you know, do this kind of error detecting. Many layers of stuff. But we have it here anyway. This is a very sort of like general purpose computer thing, I guess, is what I feel like. Where they didn't have all these layers of stuff. It was just like, you know, your TV, you know, read the signal directly. Let's see. Sorry about this dog barking. He loves barking, the poor doggy. Anyway. So this, what this CRC, this check actually does is it can only detect an error no longer than n bits, and in our case n is 32. I just had another idea. So one of the things we could do is let's keep that to the side. One of the other things I thought of doing is actually looking at the there was another SCTE35 package. I'll be good to look at that. Where in the world I put it? No worries, thanks. Oh, sorry, I don't know how to pronounce that name. Tifia? Sorry, that's so wrong. But yeah, hope it's interesting. If you've got any questions or anything, just post in this forum that we've made. I say we, but okay, we got somebody here. Oh yeah. Hi there. Look at Ben Eater on YouTube. He has some videos on CRC32, one explaining how it works, the other one being the calculation purely in hardware on a breadboard. Yeah, right. Yeah, is that something that, do you think it's worth looking at that right now? Or I feel like I really should have looked at this before. Yeah, I see. Sounds like it, yeah. So poly. Huh. That is an interesting value. OX 104 blah blah blah. Let's see if we've got that. Awesome. Thanks very much. Yeah, thanks. And also for anybody else who's watching. Woohoo. With each of the polynomials listed in the table. Now the one that we had was 4. C11DB7. Okay. CCITT. CRC32. Back to Wikipedia. Underneath the left end of the row in this example, should encode 14 bits with 3 bits there, sort of. Yeah, whew, okay. Going back to my university maths now. Nah, university is fine. High school. But, 33 bits, the CRC32. Here we go. Yeah, see, this is sort of where, yeah, Ethernet frames. Yeah, this is where I was thinking it would be, yeah. Here we go, TV. Using gzip, there you go. Yeah, there you go. Super interesting. Yeah, what do you know? What do you know? There's so much to learn, isn't there? It just never stops. Should we edit the Wikipedia article to put in this? Okay, so there's our polynomial. So that's 3 to, how's that? 32, 26, 28, 26. There's our value. Almost. For some reason we're getting, Getting 104. Are we masking there? Let's see how many bits we've got in this thing. 4, 8, 12, 16, 20, 24, 32, 40, 48. So that's 6 bytes. And this is, if I remember rightly, this is 255 values. So that's 8 bits worth of data in here. As in the possible value for each byte that we're looping through. Two minus 1. Are we using this function? Yep, there we go. Shifted 24 poly. where poly is no, not quite. Hey, how's it going? Good, thank you. How are you? Actually, no, I'm not good. This is this is yeah. Line 38. Yes, cool. Thank you. Yeah, that's it. Yeah. So CRC. Big shout out to Rebel Elder in Twitch. Co-pilot. All right, so whoops. This GitHub thing. All right, there we go. Let's put this like this, because nobody who's watching this wants syntax highlighting, right? Whoops. In fact, do is sorry, I just realized I haven't got the, so people are probably tuning in maybe not knowing what in the sweet name of whatever we're working on. Just quickly write it down for people, because I know that people sort of come and go, it seems, and yeah, nice to have it there for people. Cool. Okay, so tonight or today, wherever you are, I'm going to and we're going to do that using Go generate. It's really what we need to do. What is look, get, kill, quit? Look, get, kill, quit. Oh yeah, that is, yeah. That's it. Those are, think of them like buttons in a some other GUI graphical program. These are just commands that you can run that do stuff in the editor. Hi there. Okay, so yeah. Well, no, it is unusual. I know it looks really weird, yeah. Oh yeah. Yeah, I in U of A. There's just context. Sorry, there's somebody saying here. Everything is just emoji in the new versions of IDE. Can I pin? I do these pin things. That's bloody funny. I don't know. I find it funny. I don't know. Okay. Like CRC. Woohoo. One thing we could do is maybe just thinking how exactly to generate this. I mean, we could just like kind of like translate this code. Translate this Python into our Go. That might at least get us some progress. That might be a little bit more interesting for people to watch, because otherwise it's just going to be us sort of banging our head against the wall going, what is this thing? Especially because wanting to change it. Yeah, that's a really good question. I guess this is the only remaining bit of Comcast in the package. So it would kind of be good to not have that there. But it is a good question, yeah. Do you think maybe we should leave it then? Just so context here is yeah. Out of here. That's yeah. That's well. Not really. I mean, it is open source, and I mean we're fully compliant here. We've got 3 sort of license notices. We've got this one, which is from the original thing. We've got more than 3 notices. We've got it in the README in the package. We've got the original license file, and we also have this notice. So maybe it's not worth doing live on stream, especially since we've got an issue about it. We can certainly look at it later, especially after some research. Yeah. Okay. Makes sense. Makes sense. All right, folks. We're going to mark this then as... Oops, further. No. This isn't anybody's stream. Nobody owns this. Let's leave that. Later. Okay, I'll just answer this question quickly. Somebody asks, what is my opinion about modern syntax highlighting? Well, the main thing that people say is, imagine if you were reading a book in your native language, or in any language actually. Do you highlight the nouns or the verbs or the things in parentheses differently? You don't really, you just kind of read through it. You don't really think about it. Sometimes I feel like the syntax highlighting when we're reading things written in a programming language kind of make it feel too much like, I don't know, make it too visual, when really I feel like sometimes code, there's a way for it to tell a story, and we tell stories using language, and I feel like it just makes it a little bit easier for me to think about it like language. That's just because that's how I tend to think about it. It's important, I think, for everybody to get comfy and to try different things. So years and years I use syntax highlighting. Yeah, but I think it's cool that everybody could try different things, and everybody can try different things different times as well. Okay, let's leave that. Let's close up this CRC32 and let's change tack very quickly. We're going to do this on the spot. What I might do is I actually started doing a HLS package, HTTP live streaming, which I think would fit very well in our streaming module. Oh no, we're going to do this one. So maybe what I can do is just do a quick overview of where I got up to with the HTTP, with the HLS package, assuming it is on this workstation that I'm at now, because I think I did it on one of my other computers, which is my let me have a quick look. Bear with me for a sec. Might be in. There we go. There's yeah. Do you use syntax highlighting? Oh, sorry, not sure how to pronounce your name, but the person who asked the question. Oh yeah. That's actually a good idea. Yeah. That actually makes sense, yeah. Oh yeah, that's actually, yeah, that is actually a good point too. Yeah, I actually never thought about that, yeah. There's a fun project by a OpenBSD developer called nocolor.org. This is funny. Let me put that over here. Put that on there. Yeah. Does some amazing streams about classic Mac OS development. Really worth. I'm going to put it up here because it is. The guy's does some amazing shit. I think he's written an IMAP, email client for a classic Mac. It's brilliant. So this might be interesting. We'll put that there whilst I look for this HLS. Looks like it might be on my other computer, so let me just quickly grab that. Back in a second. Okay, I realised I had it here all along. Let's put this here. It's really great. They Josh Stein and also what was his name? Brandon Mercer. They used to have this podcast called Garbage.fm, which I think if anybody's watching this stream, you'll probably really like this. This is a awesome podcast. It's stopped 5 years ago now, but definitely worth going through if you're sort of interested in old hardware and BSD stuff, general tech things. Highly recommend it. Yeah. Alright, so I've just got my Yeah, I used to listen to that too. I loved it when the new episodes came out. It was great. Oh yeah, here we go. Okay, I found the package. Right, got our file. Sorry, folks. We'll just, okay, there. Everything now. Just check. Make sure you're right. Yep. All right. Let's get cracking already. Move this to the right place where I'd like it. M3U82 to here is a very early stages of a HTTP live stream or HLS. Let's call it just a package, but basically all this does for now is I think it can parse very, very small subset of a playlist. So I'll show you what a playlist looks like. Maybe I can just show the type. Okay. So a playlist is just no, sorry. Okay, I will try and find an example. Give me a sec. I'll go from here. Here's a playlist, and here's a playlist in its sort of real format. So a playlist is a plain text file with a pretty easy format. It's a new line delimited text file. So it always starts with a version, and then it'll have a bunch of tags. So these are things like xstream, INF, independent segments, all sorts of things. And anything that doesn't start with a tag, which is this little hash and then some text after it, is a video file that's downloaded by a player, like your phone or your browser or anything, and rendered as some images or audio or both. So if we look at one that is very boring, where I would need playlist, go. Here's a simple example here. So we've got here, in this case, our struct would look like the version would be 3. We'll have a bunch of segments, and then for each of these we'll have things like target duration, and a bunch of other stuff in there, which we'll get to that much later. But yeah, for the moment, so here's a segment, target duration, URI will be this bit here. The approach that I've taken here, do I mean live? Yeah, I do, yeah. So far we just have this one really simple function, parses a playlist from an IO reader and then just returns a playlist. It's going to be this thing. So to start off with, let's actually just see how far we got with this package. Because to be honest, I can't even remember. Alternatives. Okay. I think we've got a test running. Yeah, great. Okay, let's start up our test. Cool. All right. One thing that I want to point out. Go, people are going mad. Yeah, I know. Yeah. I know. That's yeah. The inspiration for this design comes from a very good talk. I'm trying to find. I thought I documented it, but I have not. 2 seconds. No. All good. Okay. This is a really interesting talk by one of the leads of the Go project, or at least the ex-lead or something. I don't know. One of the guys who, he came up with Go. A really interesting talk about lexing. So lexing, very, very quickly, and probably a very bad way to describe it, is essentially breaking up a bunch of, let's say, text into tokens, and the tokens that mean something. So when we lex, if I go to this playlist, here's the output of the lexer. So this thing is going to be, first it reads a tag and then a new line. And then it's got a tag, which is that. An attribute name, which is that thing there. And then a new line. And we've got a tag again, attribute name equals. Blah, blah, blah. Let me see, is that the one that we've got, XJ INF? I don't know which playlist that actually is reading from. Test data mask M3. Yeah, it's reading this thing. Okay. Imagine if you opening it and what? Yeah, that's actually, it's definitely worth saying. The guys are very, very prolific creator of a lot of computer stuff. Highly recommend reading at least this talk. I've spoken to him a couple of times at the Go conference. Really nice guy. At least when I was speaking to him, I don't know. So here's the output of our lexer, which is the thing that is read in the text and kind of turned into something that eventually could actually be parsed by a parser. So we've got here, where are we? Yep, bandwidth. Okay, so here's our version, as I said. So we're going to go through this chunk by chunk. So we get our tag, attribute name, tag, attribute name, tag, attribute name equals number. And then a comma, and then a I'm not sure. Yeah, I won't dox him. Yeah. Okay, so we got as I said, so we got an attribute name equals and then a number. So this playlist actually has let's call it a little language. So we've got numbers, we have tags, we have commas separating the attributes, and we have the what did I call this? A URL. Yeah. So we've successfully implemented the lexer for this thing. Next up, we're going to write a parser for it. So a parser in our case is going to be, sorry for the people who've actually done computer science degrees and who sort of think, this is part of me learning how to do this lexing and parsing stuff. I've always wanted to learn it. So, but yeah, as I understand it, the lexer generates a bunch of tokens, which then get passed into our parser. And then the parser will go and validate the thing and see if it makes sense. So for example, yeah, I'm going to, yeah, that'll be things like, you know, is it possible to have two attribute names next to each other? And the answer is, well, no. So it's a way of kind of breaking up the process of, like, I don't know, I guess like reading a language, something like that. I think the rules here, this thing has a bunch of rules that determines if it's valid. Those rules are the grammar. So when we try and parse this playlist, we're actually getting an error already. And our error is we're hitting an unknown attribute program ID. Let's see where we're getting to. Okay, here's, let me just set the code to always be MySpace for people, so it's just a bit easier. One of the interesting things about this particular design that that's described in this talk is that it actually uses concurrency. So where the concurrency comes in is right here. So well, let's actually do it like, this is actually concurrent process. So there's two processes. The lexer is feeding tokens into the parser concurrently. So this is like a streaming parser. What that means is that it's not reading in the whole entire file and then passing this huge bit of memory to the parser. It's actually just passing it chunk by chunk. So I'll give it a token, give it a token, give it a token, give it a token. Cool thing. Cool design. What I'm going to do is add a link to that. So we'll grab the lexer. Yeah, okay. Okay. I think where I got up to was, oh yeah, here we go. Parsing a rendition. Program ID. this would be a good little sort of take at how to parse a token from the lexer. So what we're going to do here is read. Oh, sorry, I lost our playlist. As well. Okay. So we're going to parse this particular token. So as you can see, we read a whole bunch of stuff. We're not reading program ID, so we're erroring out there. So let's add a new case. Right now, only master. If I remember rightly. So a token, or rather an item, let's call it an item. Looks like that. So I can't quite remember exactly how the lexer actually works, but what we're doing here is I think we're reading from the lexer. Oh no, okay. So in this function, we've got a channel of items. So we can read another item if we want to, which is probably what we're going to want to do. So we're going to read another item. So let's go name equals the value. So in this case, our here is going to be the value is going to be program ID, and then the item, I'm going to read in another item. And now we're going to check the type of it. What we're expecting is an equals. If it doesn't, if it's not the equals, then we need to error out. This is actually a parse error. Going to parse program ID. We expected equals, but we got this item. And then just let's run our test again and see what we get up to. Oops. Oh no, yeah, okay. Classic. Type is not an expression. Oh, yeah. And then what we'll do is, let's actually okay, yeah, so our lexer actually skips the equals. That's fine. So our lexer actually just skips over the equals, so our lexer will validate that for us. So let's go here. So let me just fix that up. So we're going to, from our items, the next value is going to be type, is going to be a number type. expected number, but instead we got that. Sorry, okay, let me get through the lexer and print out there. So int. Let's get rid of that for now. Cool. Okay, awesome. All right. Now, this function returns the variant. Okay, so what we're doing here is we're actually parsing a variant. So this is parsing a structure that looks like this. Put this stuff over here. Oh, sorry, I've gone too far. That goes to here. Okay, let's go again. So what we're doing here is we're parsing the variant and putting it into this structure. And here we are putting it into something that I don't know how to put in. So I'm reading in program ID, but I don't know where that belongs in the variant. Why don't we have a look in the spec quickly and just see where this program ID is. Look at this. Okay, here we go. So this was removed in version 6. So this program ID actually is unsupported. Now, this is a design decision. We could either support older versions of the protocol, or we could not. Version 7, if I remember rightly, is the, let's say, like a good example of the official version of the protocol, because this is the one that's actually specified in CRC32. Now, I'm sure a lot of people who know about, or rather who are actually more involved in the sort of real world business of video streaming might say, oh, well, actually version, whatever is used a lot in the wild. But, yeah. See, Rebel Elder asks, how much is version 6 used in the wild? I don't know. Maybe for the purposes of this, this project, I feel like it might be, especially just starting out, to just only target one particular version, either this version 7 or the latest one. I think they're up to about 14 now, if I remember rightly. And there's also a yeah, let me just do here. Yes, this is Apple's HLS, yeah. Try and get the nowadays there's even a like a second edition, HLS second edition, that's in That's in draft status at the moment. So we go here, there's, I think this is the one. Oh, where was it? Submission. This is the person. Yeah, okay. So they're up to version 15 now. If I remember rightly. Oh no, version 12, sorry, 12. And this is second edition. And it actually obsoletes 8216. I think for us, let's, for the stream, for the project, for the sake of it being easy documentation link, let's stick to 8216. That means version 7, which means I'm going to do that. Now that also means that we need a new test file, because the one that we're trying to parse is we don't support reading this version. So let's go to test streams.mux.dev. This will actually give us that's the one. Yeah, that'll do. M3U8. That's version 3, there you go. Maybe we should well, yeah, look, let's just leave it at that for the minute. For anybody who doesn't know, this is always a good video to test on. This is like a very permissively licensed video that was made by a whole bunch of people. And so if you're ever streaming or need a test video, this is a good one, because it means that if you ever share it around, you won't get any copyright strikes against you, which I actually got on YouTube already by showing that ABC footage from Australia. Whoops. Very good. Let's see what is in here. Doesn't even have a HC7, HQ7, yeah, okay, no version, okay, right. Let's try and parse Big Buck Bunny. Legal character dot in attribute name. Now, this is a good point. This is a bad error message. It's okay. Let's put it that way. I've got no context. I need context. Apparently, Ah, okay. We have a bug already in our lexer. So what we've got here is a tag, and then straight away we've got let me call this a value. So So the rules that we're setting for ourselves is we read this colon and then we go, okay, the next thing must be an attribute name. An attribute name is something like, this playlist is something like this, program ID. Now, if you want more information on like what, let me put it like this. I got these rules from the HLS specification, that RFC 8216. So I've kind of encoded these rules into code here. I've done that ahead of time. That's pretty boring work, right? Like you're just doing things like saying, the characters between, from A to Z, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, dash, blah, blah. Just reading the spec and just, being like a robot translating it into code. Now we've got a bug, as I said, where we're reading this thing. So just trying to think of a way in our lexer to cover that. So what we're doing is maybe I should have gone through. I didn't expect to have to look at the lexer again, but I can just try to explain it now that we're here. The lexer works by reading in text from this scanner. What it's doing is it's reading in line by line. And then it uses this thing called a state function. And how this works is that you call, what's the one you do? You call lexer start, was it? Run, yeah, that's it. Okay. Here's the lexer's sort of main loop. So what we're doing here is that we're starting with lex start. So this is like the state that the lexer is in, and lex start is reading that particular tag. That's it, because that has to be at the very top of the file. That's the rule. And what we do is that we go along and we keep setting the new what do we do? Sorry, we run this function, which is lex start, and then we set the new, and then whatever whatever that function returns is what we actually set as the new state of the lexer. Let's just do an example because it's a little bit confusing. So here's the bit where we actually read through the text. Let's start here. So what we do is that we skip blank lines, new line, and then eventually we run lex tag. Now, how do we lex a tag? Well, it starts with a hash. That's pretty much it. And then we read the characters one by one. Next, 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 next. It's here. We read character by character until we hit a colon. When we hit the colon, we then emit the item. So what that means is that we just pass it on to whatever's going to be receiving this stuff. In our case, it's a parser. So this is here. Now, after we've emitted the item from the lexer, we move on to the next bit, which is going to be lex the attributes. So if we go to this example here, token, we read through each, so we read rune, or say each character, colon, okay, time to read an attribute, time to read an attribute. So we return this function here, which is lex attributes. So that's program ID. So we try and lex that thing. See how this looks. This is pretty similar to what we've seen. We go, yep, that's a valid character, valid character, valid character, blah, 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 blah. And then, depending on what we see next, we move on to the next state of the lexer. Either we do something like an equal sign, or we may see a comma, for example, or we may hit a new line, which means we're at the end of the attribute. So depending on what we hit, we put the lexer into its next state. I just realized I haven't had my mic on me the whole time, so maybe it's going to be clearer if I do this. Sorry about that. Oops. Cool. All right. Ah, cool. Okay. Cool. Good, good, good. Thanks. All right. Yeah. So back to our, let's call it our bug. So our test is failing because we are lexing a tag. Oh, sorry, let me get to the right. Okay, yep, we're lexing the tag name, and then we hit a colon. That's this guy here. And the next thing we try to do is we lex the attributes. But that's actually not what's happening. What we're hitting straight away is a, it's kind of like a raw value. So we want to account for that somehow. I'm not sure how to though. So what we've got available to us in this function is the lexer, and this lexer can do a few different things. It doesn't just have some text in its buffer, it has a few tricks up its sleeve. Things that it can do are it can go backwards. It can have a look at the next character. It can emit errors, it can emit items, that sort of thing. So oh yeah, and it can skip over characters that it doesn't care about. What we could do here is still try to lex the attribute, but if we don't ever hit an equals, or maybe if it just has a dot in it, maybe that dot is going to be our special rule. Because if it consists of only numbers and a dot, then what it actually is a number. Yes, this is the Go mono font, yeah. What we can do here is maybe choose the attribute value and then I do, yeah. This is a tricky bit. So our lexer is looking ahead to the next character. One thing we could do is one of the things that we could do is actually from here we could just not emit but try and go straight into, so if we hit a dot we could try and lex an attribute value. Unquoted string starting with a legal character. Okay. Sort of, kind of, not quite. Not quite there. We could try to have this open just in case I'm missing something on Twitch. I always forget to have these things open.
Or you can just
yeah, here we go. Unquoted string starting with a legal character. I wonder if a tag, if an attribute name can have numbers in it. If it can't, then that would be a great way to just move on. Let's knock that out in the meantime. Yep. I've got it. Okay, so, all right, hold on. So what we're doing here is we're saying, hey, try and lex an attribute value, which is going to be something like a number like this or whatever. Here we go. This needs to contain a dot because that's actually valid in a number according to the spec. I remember reading that, I just haven't done that. So that's, if we go there, woo, nice, there we go. Easy bug. Now in our test, let's try and print out the actual playlist. Let's see what it thinks there is. Because apparently we can parse it as well, which I don't remember doing, but hey, any code that I don't remember writing but is actually there doing stuff is okay by me. Let's do this. There's our playlist. We get a, and let's open up our, where's our go doc? There we go. There's a playlist here. So we're getting a version of 3. We've got no segments. Target duration of 0. Your continuity is 0, blah, blah, blah. The type is an event, apparently. Unless that's just 0, which it is. Okay. Event segment is false, start nil. Okay, all right. Let's have a look at our parser now. One thing that we're probably not we're not looking at yet is pretty much everything. What I mean by that is that we're reading the version tag, we've got the variant tag, and we're doing the rendition tag, but we're not getting any of these things. So let's start to read these things. Tag playlist type equals like that. Now we can go down to here are a couple of messages. Sorry about that, missed it again. Let's have a look. I work with that IDE. Yeah, yep. I've done a lot of work, both paid and unpaid, with this. With this program. Yeah, good little program. Data tracker, direct link to what is this as an attribute key value. Yeah, awesome. And for URI's playlist. That's good. I'm going to keep that open over here. All right, let's keep going. So we read our, so now we've got a, the tag name stored as a constant, which is good. Let's configure our parser to be able to recognize that tag. So in here, we're going tag version, variant, rendition. Let's just add a new case, super easy. It's gonna be tag playlist type. And the playlist type, I think, comes in here. Okay, yep, playlist VOD. All right, easy. So, playlist type is going to be some, oh yeah, I can't remember. There we go, let's open this. Oh, playlist type, okay, here we go. Now one of the things I like to do is actually link the section of the RFC here. So this is the same as, and the reason I like to do this is one, it's really useful. 2, it's actually what the Go standard library does as well. So if you look at method get, at least if I remember rightly, they do that, or not. No, there's another one I want to get is the statuses maybe. Yep, here we go. Let's do this exactly the same. 8216, just like that, and we'll add the others later, right? Genuine asks, do I need to learn compiler design to be able to write parsers, or just understanding algorithm recursive descent is enough? I don't know. I don't want to speak with any authority on what is needed to learn to write parsers. Let's call what we're doing now an exploration. Yeah. I think this is one of these times where we're just exploring stuff and we're learning some stuff. I'm pretty sure this is a recursive descent one, because we only ever we only ever go in one direction from the top down. But yeah, I'm definitely not qualified to answer that question. Sorry. I know that there's a few really good videos about parser design on YouTube. Like really good, like kind of like a really general overview, not detailed. It was from Computer File, recursive. Yeah, this was it.
I actually think
this is a great video. Because it actually has nothing to do with programming languages. It's just about language. So he gives an example of a sentence in English. I think it's really clever. He goes through recursive descent and the bottom up one. I can't remember what these are called. But yeah, that's all I'll recommend, because I'm definitely not qualified to talk about that sort of thing. Here we go. Yep, and so genuine. Somebody recommends also these books. Craftinginterpreters.com. Yeah, that's right. Yeah. Yeah, I have that one bookmarked actually. Somewhere in here. Yeah, anyway. Hope that's helpful. Now, where were we? Get the equals parse play with type, and then we're going to give it let's just give it the item. Get this new function, little function to parse a playlist type. it's going to give us back a, in our case, it's going to give us back an actual playlist type thing. So let's playlist type. Oh, and an error, of course. All right. So from here, we're going to, let's do a switch on the item value. So switch it.value. No, we're going to do it. First up, let's just do a quick type check. We know that this needs to be a number. And if it's not, then we, oh no, sorry, wrong. This is a, this is an unquoted string, at least in terms of the HLS spec. So let me just look at our lexer again and see what types we've got for us. Item string. Is that it? Okay, yeah, so we're gonna have a string and then we'll be able to unquote it ourselves. I feel like we almost need another item type in there for a string versus an unquoted string because they're quite different. But anyway, let's just read the value. Does not, so if we don't get a string type, then we're going to return, you know, was it a 0 and then now we can have a read of the version. So we could get anything here. We've got a string, but the only two values that we permit are the literal characters VOD or event, I think it is. Let me just double check. Now that I've very handily done the section, I can just look at it. There. Yeah. Oh. Oh. That's what you're saying. Rubber Elder was the, yeah, okay. The thing here is playlist type. 4.4 point, okay. So it can only either be event or VOD, okay? So if it's event, then we return one of our constants. Now this is weird. Sorry, I'm missing something. Playlist type, here we go. Yep. Is a, so if we read the thing event, then we return event. Nil. Otherwise, we return that, and then Yeah, it's us. Now, back in our parser, now that we've read the type, we can just go, we can insert it or sort of like set it in our struct. So p dot playlist type equals the type that we parsed. Playlist has no method field or method playlist type. Oh, is that so? Oh, is it just type? Probably. Yeah, it should just be type. If it's not, then we should change it. Yeah, because we're in a playlist type. Okay, fire parse and as one. Ah, yeah, okay. Cool. There we go. If we go down. Oh, okay. We failed, so let's. Yeah, okay. Parsing the tag playlist type. Parse the tag. One item string got tag. Let's improve that error message a bit because it's a little bit misleading. Well, it's not as clear as it could be. We want the so we're going to do, this is actually, we don't need this here. We want just the item, but we want item type. So we got this item, but what we wanted was an item type of string. It's a bit shorter, but it's even clearer, I think. Yeah. Yeah, parse playlist type. We got a tag with a value of that, but we want item type string. That's better. Oh, of course, we need to read the next token. So yeah, we need to read the next item out because we read that, we go, okay, that's fine. Let's try and the very next item should be a string. Oh, shit. So what we do is so we've hit tag playlist type. Okay, let's read the next item. So we read from the channel. And then we go again. Next thing we need to do is parse the playlist type. Son of a bitch, what are we on? L? Oh, lex.item, sorry, yeah. Let's try again. Interesting. So our item from the lexer is VOD. Sorry, our item from the lexer is an attribute name type. So go back to our lexer. We're getting a type attribute name. Let's step through this thing. Reading the tag name, and the next thing we get is an attribute name. Now the attribute name, really what the type is, it's like an attribute name or an attribute value. That's a tricky one. It's an attribute name in the sense that it's it is valid in the sense that it's not just a string, which is a quoted thing. I'm almost tempted to accept because to the lexer, it is an attribute name. Quite sure how to handle that. Maybe what we could do is just, as I said, just like accept that it's an attribute name, and then maybe there we go. Here's a parse test. Let's print out this. Oops. Oh, I haven't got my formatter running. Cool. Event type is VOD. Next would be the target duration. Let's go through that. So we go back to the top of our parser. Let's put this here. And we are currently not able to parse this, so let's go again. So tag is target duration equals that thing. Let's find where this is. 4.4.3.1 apparently. Okay, cool. And then, give me a sec, my phone's just ringing. Put this here. Whoops, wrong program. OBS. Oop, that's not right. Hey, okay. I'll go for. What I'll do is I'll go now for another 20 minutes, half hour, and then I will have dinner. And we'll say thank you very much for watching. But let's I've dived into this, or dived. Yeah, we've taken a dive into this HLS stuff much earlier than I thought. But I think it should work out, because what we'll do is that we'll actually be able to insert SCTE35 messages into a playlist, all in Go, and then finally render a playlist programmatically. It should be good. So I think doing HLS is actually a good step, especially because I've already done all this sort of legsing stuff. So makes it, let's say, makes it easy to debug. I've spent quite a bit of time doing the code to do all this stuff, so it makes the error messages clearer and all that. So just double check that YouTube is okay, because I am paranoid about it, because they're getting weird stuff going on. Oh my god, there's still more people subscribing. This is look, this is, thanks everybody, and really, I really hope this helps people, because the community and reading all this open source stuff and people sharing this stuff has really helped me a lot. So yeah, that's awesome stuff. Alright, let me just check, just going to the so-called control room in YouTube. Yeah, it looks fine. Okay. Who remembers what we were doing? No, okay. So let's add support for our parser to parse the target duration tag. This should be quite a good one, okay? The reason why I think it'll be cool is because, if I remember rightly, we're actually, if we go to our playlist, the duration is actually going to be a time.duration, which is going to be very cool, because we can do all sorts of cool shit with that. We're using a typed language, so let's take advantage of the types that we've got. It's not super duper typed, but I don't know if there's any Haskell programmers in here, or Scala. Okay. Item tag. Okay, yep, next tag. Tag, what was it? Tag, target duration. Target duration, yeah, okay. Do the p.target duration equals 0. Let's do our little parse target duration. This is going to be a tribute name, which is a bit yucky, but that's all right. Let's do an or in here, just to stop. Not equal item number. Then let's error out. now we need to, this case, parse a number. I don't know whether we've written that function or not. Because, see, a number in the HLS spec is, it's not an integer. A number is, it can be, you know, it can have a dot in it, so it could be like 10.00. So it's either an integer or a float in Go, sort of in Go types. In this case, a target duration. Let's read the spec just to see exactly what that really means. Because I'm pretty sure, off the top of my head, it's just a number of seconds, but let's check the spec. 4.3.1, okay. And to the nearest integer must be less than or equal to target duration. When rounded to the nearest integer. Yeah, okay. Decimal integer, what does that mean? As described in section 4.2. An unquoted string of characters from this 0 to 9 exponential decimal integer maybe. Okay, great. So in this case, we can actually be a little bit more strict. We can actually say we are absolutely expecting an integer. So let's do our strconf. So we're going to go a to I. And then our duration is just going to be the seconds. So it's I times time dot second. I always forget whether I need to do a type conversion on that. The compiler will tell me. Yeah, mismatch time int and blah blah blah. Okay, so time dot. Oh yes, very clever. Okay, and awesome, 11 seconds. Woo! Big thank you to the audience for suggesting that we move on from CRC32. This is a lot more satisfying. That's Rebel Elder again. Great. Let's look at our playlist and see what the next value is. Oh, what's that? INF. Okay. Can't remember what this actually. Oh, 4 point, oops. The duration of a media segment. Yeah, I mean, I knew that, but is that, how do we represent that? M type. Oh, it's a segment. what I'm looking at is how to manage our parser going from these fields into this thing. So perhaps the parser itself needs to have a bit of, needs to have a bit of state, because if I understand it correctly, the in the spec, so if we go to this one here, sorry, this one we're looking at. So once we hit a tag like this, I think from that point until we get to a URL, as in the thing, like until we get past all the tags, that describes a segment. So we can have a whole bunch of other things in here, which can be like, as you say, the duration, the range, discontinuity. Yeah, that's right. Yeah, because we can have this in here as well. If you remember that, if anybody was here yesterday, this is what we were hitting. Discontinuity. This is actually how we do breaks in HLS. But all of this describes a segment. So code-wise, we're going to have, I'm going to have our parser. It's going to have a bunch of like different, let's say, like states. We've done just what are kind of like the, I don't know how quite to do it, but these sort of things that are describing the media playlist. So let's do, so one state is doing like sort of media playlist parsing. Another one is segments. And then another one is master playlist. And then there's some others that can be as I've done here, can be in both a master and a media playlist. Now these master and media playlists, by the way, are things that are just, a master playlist has a, let's say like a number of sort of, how do I describe this quickly? Let's look at this. This is a playlist which contains other playlists. These are the different bit rates. So say you've got a slower connection to the server that's giving you the media, you'll probably take the lower bit rate. If you've got a really great connection, you'll take the highest bit rate. It's the bandwidth. And when you're reading when you're playing stuff from a playlist, the player will often adjust between different ones as it goes. So the easiest way, we're probably all familiar with it, is when you're like watching a video, and when you very first start the video, it's kind of all blurry and like you can't really see it. You're probably reading from the low bitrate playlist. But the player knows that when things get better, it can switch to higher bit rates. So it'll kind of have all of these things in its back pocket ready to go. So that's a media playlist. Sorry, that's a master playlist. The media playlist is going to be the contents of this one. So our parser needs to handle all of that. Yeah. And where we were at yesterday with SCTE35 was we had a, what was it, a variant? Rendition? date time, that was it. So we were describing a segment using the date time. So it looks like we're going to have to swap this. We're going to have to work on this a bit if we want to support stuff like SCTE35 and who knows what else. This is just something that I drafted up a while ago. So in our playlist, we'll have a bunch of attributes that contain SCTE35 encoded as base 64. Yeah, so I think that we're good to leave it there for now. So what I'll do is I'll publish this onto I'll push this to our Git repository, and yeah, we'll just see, like, and tomorrow I think maybe we'll swap over all the way to working on HLS, if that sounds interesting. Let me swap over to this thing. Yeah. So let's fix this thing up, because now we can write to discuss at Ooh. No worries. I'll just put the little let's get this right. 188. Oh yeah, there we go. No worries. Thank you. Oh yeah, see this? Look, we've hit 53 followers on Twitch, which means that that you're allowed to start playing ads, which we're not going to do. Fuck them. Just go back to YouTube here. No, they do it after you hit a certain number of people. Oh well, actually, I don't know. I think I think at 50, I don't know. There's something about the ads and like how you can set ads to play yourselves, and like you can ask to get paid some of it. But it's not worth, I mean, no. Not cool. Oh, somebody's saying here, Can I upload a better quality video onto YouTube? Yeah, I might have to look into that. I wonder whether, I guess the text is clear and all that. But anyway, okay, let's oh, good, yeah, great. Yeah, as I say, thanks everybody. Got any questions or suggestions or anything, like just email it in there. Yeah, might switch over to SourceHut, I think. Yeah, because you've got to, then we don't have the problem of the getting accounts and all that. At least I don't think you need to log in. It's weird. Like, anyway. Yeah. Thanks everybody, and I'll see you tomorrow. I'm going to be starting earlier again tomorrow, so whoever's awake at that time, we'll see you then. And if not, we'll see you later in the day, or in the night, or in the morning, however it goes. Okay. Thanks everybody. Cheers. See you next time. Thanks. See you.